So, hi students, so today we'll be discussing the module 2 in physics, electrical conductivity of solids. Okay, so this is syllabus. So first of all, go to the quantum free electron theory. So this is a very important questions also. So energy values of the conduction electrons are quantized. That is the first point. The distribution electrons, okay, are allowed as per Pauli's exclusion principle. In the sense, only 2 electrons can be there in one particular shell. The electrons travel in a constant potential inside the metal but stay confined within the boundaries. Then obviously the electron will be repelling. That is the fourth point. Then energy bands. So there is something called forbidden band or the energy band gaps. So the electrons cannot travel or electrons will not be there in that particular energy gap or the band gap described according to the classical free electron theory. So this has been proven against by using the quantum theory of free electrons. Okay. And then there are two bands. One is conduction band, another is valence band. Okay, so the gap between the conduction band and the valence band is called the forbidden band or the energy gap. So Fermi energy, I told you, Pauli's exclusion principle. Maximum 2 electrons only it will be, which already we studied in class 11. So coming to the Fermi energy, the energy occupied by the highest, the energy of the highest occupied energy level, correct, at 0 degree, at absolute, is called Fermi energy or Fermi level. Diagram is important. So draw diagram. Fermi factor. At temperature above the absolute zero, that is above 0 degrees Celsius, the material will be receiving thermal energy from the surroundings. So the electron just below the Fermi level absorb the thermal energy and will occupy the higher empty levels. And that probability is given by this, where this F of E is called the Fermi factor, 1 by 1 minus E minus EF by KT plus 1. This is basically the probability. Okay. Then dependence on Fermi factor at various level. If it is at 0 Kelvin, put T is equal to 0. Then I'll be getting F of A is equal to 1. Probability is 1. At absolute temperature 0, the probability is 1. That is 100%. Okay. When E greater than EF, then the probability is 0, which means all the energy levels are unoccupied. Ordinary temperature will be half, that is 50%. So first it is 100%, then 0, then 50%. Draw the graph and study. Expression for electrical resistivity and conductivity based on quantum free electron theory. It is sigma is equal to Ne square by M, lambda by Vf, where lambda is nothing but the mean free path. Dielectric. So the moment dielectric comes to in our mind, we should know that dielectric is nothing but a simple insulator. That's it. Electric dipole. Dipole is nothing but two equivalent opposite charges separated by a distance. There is dipole. And this is a dipole moment, mu is equal to Q into R, where R is the distance between the two opposite but equal charges. Polar dielectric. See the example. All are compounds, non-polar, it is all are atoms, individual atoms. Okay. One minute. Yeah. So type of polarization process, learn the headings. There is electronic polarization, ionic polarization. So polarization happens by the process of electric field. That is electronic. Polarization happening through ions. Then orientation, that is through spatial polarization. Self-readable. Learn the diagrams for each and everything. And the most important thing is the Clausius-Mossotti relation. Okay. So dipole moment per unit volume. N mu. Then mu is equal to alpha EI. Okay. EI is the internal electric field. Dipole moment per unit volume is nothing but what? N into alpha EI. In the sense, this alpha EI is there, no? That is basically mu. I'm substituting 2 in equation 1. Seeing itself, will come to know. Everything is written step by step. P is equal to N alpha EI. EI is equal to P by C. From this itself, I am calculating EI. So this will go down. Okay, so P is nothing but epsilon naught. This already we should know this value, epsilon naught minus 1 into E. So instead of P, what is it? Epsilon naught into epsilon naught minus E. So E is what? P by this. Correct? So EI is nothing but what? EI is nothing but E plus sigma P by epsilon naught. Okay, instead of E, what I'll put? This. This is my gamma, not sigma P, gamma P. Okay, or nu P, you can say it. But whatever it is, put the same symbol in the examination. And internal electric field gamma is nothing but 1 by 3. So instead of this, you put 1 by 3. Okay. And rearranging the values, we'll be getting what? N alpha E by 3 epsilon by equal to epsilon r minus 1 by epsilon r plus 2. These are all in the subscript, epsilon r. Okay. See, you can see here, these are all epsilon r is in subscript, not superscript. So that is the Clausius-Mossotti relation. Read the examples for solid, liquid, and gaseous electrics. Application directories, read it, transformer, insulation. As just remember only one thing, directory is nothing but insulator. It does not allow the current to pass through it. Superconductivity. Okay. So you can see the superconducting phase here and non-superconducting phase. So again, diagram is important than this. Do not read what is there below. Just draw diagram and explain your own words. Whatever I discussed till now, put it same on the paper. Effect of magnetic field. So the minimum magnetic field required to switch an material from its superconducting state to normal state. So obviously we have to apply an external electric field or magnetic field to make sure that it is coming out from its superconducting phase to the normal phase. Draw diagram and remember this value, superconducting phase. Meissner effect. So the phenomenon of expulsion of magnetic lines of force from the interior of a superconductor when it's cooled below its critical temperature in a magnetic field is called Meissner effect. So it is a perfect diamagnetic material. Diamagnetic in the sense all electrons are paired. Paramagnetic, all electrons are unpaired. So it's a perfect diamagnetic material. Draw diagrams. Type 1 and type 2, draw diagrams. Yeah, draw diagrams in this and write in your own words. BCS theory, Barton Cooper. So BCS theory is important. So this is basically what electron lattice interaction, formation electron pair bond known as copper state pair state, and normal metallic state with this free single electron becoming unstable. So copper pair is nothing but interaction between electrons with the opposite spin and momenta in a phonon. Okay, so this already we have learned in our class 12 in semiconductor chapter. Phonon might not be there, but the other things will be there. Okay. Application. MAGLEV vehicles, draw diagram and study SQUID. superconducting quantum interference rate. This is very, very important. They might ask it. So study the diagram in this also. Two diagrams. Draw diagrams properly. And I is equal to I naught cos 2 pi E phi by H. That also study. Then coming to the most important thing, problems. Symbol substitution. Calculator is there. Put this Fermi energy thing. Calculate the probability of electron. Correct? Probability. Obviously, the answer will be less than 1. For any question, if you're getting more than 1, then our answer is wrong. Substitute in this, whatever values are there, that's simple substitution. You'll be getting it. All the problems is based on simple substitution. That's it.